Now we can scroll up again. We have this revert if health factor is broken, which is still busted because this function doesn't do anything. But now we can actually have it do something because we have this health factor here. We're going to update our health factor function because now we have the two of these. What we can do is we can just get the ratio of these two. So we could say collateral value in USD divided by total USD minted. This is what we're going to return for a health factor, right? Well, not quite. So let's say we have 100 collateral divided by 100 DSC, right? This is 1-to-1. If we go down a penny, we're going to be under collateralized, right? And we don't want to go under collateralized. We always want to be over collateralized, because if this ever goes below 100, our system is bunked up, right? So we want to set the threshold to be like, hey, if you go under 150 collateral, you can get liquidated, right? If we go under 100, it's already too late. So we want to say, hey, we want you to go at least 150. So we're going to create a liquidation threshold, and we're going to do this at the top. So we're going to say uint 256 private constant liquidation threshold equals 50. And this means you need to be 150, or no, this means you need to be 200% over collateralized, I think. It might be 150, but we'll find out in the test. So now if we go back down to where we were, to get our health factor, we're not just going to divide these two. And even this doesn't really work, because if we have 150 over 100, 150 divided by 100 is equal to 1.5. Decimals don't work in Solidity, so it would just be 1. I guess that would work. But we want to know exactly what the health factor is, right? With precision. So first off, let's, instead of just doing this, let's say uint 256 collateral adjusted for threshold equals the collateral value in USD times liquidation threshold. And then we should divide by 100, right? Because the liquidation threshold is multiplying. It's making our number much bigger. We should divide by 100, as I don't like floating numbers. So we'll do uint 256 private constant liquidation precision equals 100. So we'll go back down, divided by the liquidation precision. So now we have this collateral amount adjusted for this threshold, right? So now you can kind of think of it as, instead of, say we have $150 of ETH divided by $100 of DSC, right? This would be 1.5, but now they need to multiply by 50 as well. But now this collateral value is multiplied by essentially 1/5, right? Let's do the math here, right? If we had, say, $1,000 of ETH, we just times that by 50, which gets us to 50,000. But then we divide by that by about 100, which equals 500. So if we had $1,000 of ETH times 50 equals this, divided by 100 is 500. Same thing with this example down here. If we had $150 worth of each ETH, we say 150 times 50 equals 7500 divided by 100 equals 75. And then if we do 75 divided by 100, that is going to be definitely less than 1, right? So we're basically saying with this 50 threshold, 50 over 100 is essentially 1/2. We're saying you need to have double the collateral in here. So yeah, so now that I'm talking it out loud, this 50% liquidation threshold means we need to be 200% over collateralized, right? We need to have double the collateral that we have the minted DSC. Anyways, so a whole bunch of math. Hopefully this makes sense. If not, definitely work with your AI to make sure this makes sense, or ask questions in the discussion, right? I know some of this math can get a little bit tricky here. So collateral adjusted for threshold. And now we can return the collateral adjusted, this collateral adjusted for threshold times precision divided by that total DSC minted. And now this will give us our true health factor. And if this is less than 1, you can get liquidated. Now, this is one example, right? Let's look at another example. Let's say, I guess this is 2 examples. So let's say they have $1,000 worth of ETH and 100 DSC, right? So let's do the math here. 1000 times 50 equals 50, 1, 2, 3 divided by 100 is equal to 500, 500 divided by 100, which is definitely greater than 1, right? 500 divided by 100 is 5. So this person with $1,000 of ETH deposited and 100 DSC minted would have a health factor of 500. Nice. So now that we have a health factor, we can actually finally do this revert if health factor is broken function, where we say, we can even put this above this as kind of like a pseudo nat spec. We could say uint256 health factor equals underscore health factor of the user. And we say if the user, excuse me, actually let's do user health factor. And if the user health factor is less than the some min health factor, which is going to be 1 health factor. So let's go ahead and create this. Let's go to the top because we hate floating numbers. uint256 private constant min health factor equals 1. If the user health factor is less than the min health factor, then we're going to go ahead and revert. I don't love this. We're going to do DSC engine underscore breaks health factor. We're going to pass in this health factor that we break with. Boom. New error. Scroll to the top. Error. Engine breaks health factor. uint256 health factor. All right, looks like we still have some red here. What did I forget? Okay, revert if health factor is broken. Underscore like this. Boom. Now it looks like nothing's red. Let's just make sure. Forge build. Successful. Nice.